Well, the CBSE question on inelastic collisions. The problem is like this. A ball moving with a velocity 2 meters per second collide head-on with another stationary ball of double the mass. This is the important part. If coefficient of restitution is 0.5, what is their velocities after the collisions, right? So this is the inelastic collision because coefficient of restitution is not equal to 1. Then how do we know what is the velocity for final velocity after the collision? You could have at least known one equation that we have learned for an elastic collision as m1 minus m2 by m1 plus m2 of u1 plus 2m1 by m1 plus m2 of u2. This is the derivation that was being made. Even it is done in our playlist. You can see this. This is for elastic collision. For a perfect elastic collision. But for a inelastic collision, for not a perfect collision, for not a perfect elastic, where E is not equal to 1, of course it's greater than 0. It's generally greater than 0. How do you write a formula? It's actually very easy. You can write that as m1 minus em2 by m1 plus m2 of u1 plus 1 plus e times of m1 by m1 plus m2 of u2. How do you remember that, or how do you identify that this is the correct one? See, for a perfect elastic collision, E equal to 1. In this equation, in the place of this E, if you put 1, you shall get back to the original equation. Check that. E equal to 1, then it becomes m1 minus m2. Same. Everything else is anyway same. Similarly, here E equal to 1 means 1 plus 1 means 2. Here you get 2m1. Everything else is same. That's how we shall remember. We have to write an equation. Of course, there's a derivation, but if it is difficult for you to remember that, this is the easy way to remember that. You know this original equation. In that equation, you have to put E in such a way that you put E equal to 1, we shall get this equation. That's the basic thing, right? Let's solve that part of the problem first. Let us see what happens. V1 equal to head on with a stationary ball of double the mass. If m1 is m minus coefficient of restitution is 0.5, m2 is 2m by m plus 2m of u1 plus other part is 0 because second body is initially stationary, u2 equal to 0, so everything else is 0. 0.5 is 1 by 2 into 2, this is equal to 1, m minus m equal to 0. So v1 equal to 0. There is only one option with v1 equal to 0, so that's obviously our answer. You can choose that answer. You need not solve further. But anyway, I will solve for you. I will also tell you that how do you write an equation for second velocity. For that, first I will write for an elastic collision, for a perfect elastic collision. When I say perfect elastic, it's E equal to 1. V2 equal to 2m1 by m1 plus m2 of u1 plus m2 minus m1 by m1 plus m2 of u2. Then for E that's not equal to 1, of course, but greater than 0, V2 can be written like 1 plus E times of m1 by m1 plus m2 of u2 plus m2 minus E m1 by of u2. How do I check whether this equation is correct? Again, simple. In the place of this E, if I put 1, I shall get back the above equation. Check that. If I put E equal to 1, 1 plus 1 becomes 2. This is same. Here also, if you put E equal to 1, it becomes m2 minus m1, that is the same. So, it's very easy to remember these equations once at least if you know this basic equations. This you shall know at least. These are derived in my playlist also. You can check. From that you can derive that. Now let us substitute this data and to get an answer. Yeah. 1 plus E means 0.5. M1 is M plus 2M. And U1 is equal to given as, this is U1, yeah, given as 2 plus 2M minus 0.5 into M by M plus 2M. Of course, U2 equal to 0. So this term doesn't make a difference, becomes 0. 1.5 times of M by 3M and 2. So M and M will cancel. This is 1.5 is 2. 2 by 2 equal to 1 meter per second. So the second body shall have a velocity of 1 meter per second. That's how we get into that answer. But be careful in understanding one thing, that equation final velocities for not perfect elastic collision are slightly different from elastic collisions. But how do I remember them is, wherever you get E, in the place of that E, if you put 1, you shall get back to your original equations of perfect elastic collision. And of course, you shall know the equations for perfect elastic collision. Once that is done, it's easy to identify. That's how you solve the problem. Thank you for watching.